What if I told you that spending just 5 minutes here could mean years have passed somewhere else in the universe? This isn't a scene from a sci-fi movie. It's a real phenomenon that happens near black holes. These cosmic mysteries don't just bend space. They completely shatter our understanding of reality. So, get ready. Because today we're diving into 10 mind-blowing facts about black holes that will forever change how you see the universe. Let's start with a big one. Most people picture black holes as giant cosmic vacuums, indiscriminately sucking up everything in their path. But that's a common misconception. The truth is, a black hole's gravitational pull is only inescapable if you get too close, past a point of no return, called the event horizon. To put it in perspective, if our sun were magically replaced by a black hole of the exact same mass, what do you think would happen to Earth? We wouldn't spiral into oblivion. We'd simply continue our orbit, just in total darkness and freezing cold. No instant destruction, just a lonely, dark journey through space. So, a black hole is less like a vacuum cleaner and more like a celestial trapdoor you have to step on directly. Now, let's talk about time. This is where things get truly bizarre. As you approach a black hole, the intense gravity causes time itself to slow down. This isn't just a theory, it's a core prediction of Einstein's theory of general relativity. And it's been proven by real-world experiments with atomic clocks. Imagine you're on a spaceship orbiting close to a supermassive black hole. For every few minutes you experience, years, decades, or even centuries could pass for someone watching you from a safe distance back on Earth. You could take a short trip and return to a future you wouldn't recognize. The universe's ultimate time machine might just be a black hole. And yes, you've probably heard the term, but let's confirm it. Spaghettification is a real and terrifyingly literal scientific term. If you were unlucky enough to fall into a black hole feet first, the gravitational pull on your feet would be exponentially stronger than the pull on your head. This immense difference in force would stretch your body thinner and thinner, like a piece of spaghetti. It's a gruesome thought, but it's a fundamental consequence of extreme gravity. So, when you hear astronomers talking about spaghettification, they're not joking. It's the universe's most brutal stretching machine. You might think that something as powerful as a black hole would last forever. But surprisingly, they don't. Thanks to a brilliant discovery by Stephen Hawking, we know that black holes slowly evaporate over time through a process called Hawking radiation. Tiny quantum fluctuations at the edge of the event horizon cause particles to pop into existence, and some of them escape, carrying away a tiny bit of the black hole's mass. Small black holes would evaporate in a flash of energy. The supermassive ones, however, will take an unimaginable amount of time, trillions upon trillions of years, far longer than the current age of the universe. But eventually, even these cosmic giants will fade away into nothing. Speaking of small black holes, some might be smaller than a single atom. These are called primordial black holes, and scientists theorize they could have formed in the chaotic moments right after the Big Bang. Don't let their size fool you. A primordial black hole smaller than an atom could still have the mass of an entire mountain. If they exist, they could be drifting all around us, completely invisible. They might even be a component of the mysterious dark matter that holds our galaxies together. Imagine a mountain-sized mass compressed into a space smaller than a speck of dust, silently floating through the cosmos. Almost every large galaxy we've observed, including our own Milky Way, has a supermassive black hole lurking at its core. Ours is named Sagittarius A star, and it weighs about 4 million times as much as our Sun. These behemoths aren't just passive residents, they're active architects of their galaxies. The immense energy and jets they release can trigger or halt star formation, influencing the evolution of the entire galaxy around them. Without these central giants, it's possible that galaxies like ours, and by extension, life itself, might not have formed in the way they did. They are the monstrous, beating hearts of the cosmos. What happens when two of these giants collide? The universe literally shakes. The merger of two black holes is one of the most violent events imaginable. In the final fraction of a second, before they combine, they release more energy than all the stars in the observable universe combined. This cataclysmic event sends out powerful ripples in the very fabric of space-time, known as gravitational waves. Yes, you heard that right. Space-time itself can ripple like the surface of a pond. These waves travel across the universe at the speed of light, and our advanced observatories can now detect them, allowing us to listen to the cosmic echoes of these titanic collisions. The power of a black hole isn't just about pulling things in. Some of them, especially those that are spinning incredibly fast, can act as cosmic slingshots. If a star passes too close in just the right way, the black hole's rotational energy can catapult it out of its home galaxy at millions of miles per hour. These are called rogue or hypervelocity stars. They become homeless wanderers, doomed to travel through the vast, empty void between galaxies for eternity. Imagine a star, a sun like our own, flung into the darkness, completely alone, on a journey to nowhere. Now, for one of the biggest paradoxes in all of physics, the black hole information paradox. Here's the problem in a nutshell. According to quantum mechanics, information can never be destroyed. It can be scrambled, but it always exists somewhere. But according to Einstein's theory of general relativity, anything that crosses a black hole's event horizon is gone forever. So, what happens to the information of the matter that falls in? Does it disappear, violating the laws of quantum physics? Or does it somehow escape, which would violate the principles of relativity? Both theories are pillars of modern physics, and both can't be right in this context. It's a puzzle that has stumped the greatest minds for decades, and solving it could unlock a completely new understanding of reality. And finally, we arrive at the most mind-bending idea of all. Some speculative theories suggest that black holes could be gateways to new universes. The extreme conditions inside a black hole, the singularity, the point of infinite density at its center, could trigger a new Big Bang, creating a baby universe on the other side. If this is true, then every single black hole in our cosmos could be a seed for another reality. And it leads to an even bigger question. Could our own universe have been born from a black hole in a parent universe? We might be living inside the creation of a long-dead star from another cosmos. Black holes are terrifying, beautiful, and the ultimate cosmic enigma. They challenge our deepest understanding of space, time, and existence itself. And the more we learn, the stranger and more wonderful they become. They remind us that the universe is far more complex and mysterious than we can possibly imagine. If these facts blew your mind, make sure to hit that subscribe button and turn on notifications. We're just getting started on our journey to explore the deepest secrets of the cosmos. Thanks for watching.